I'm Erica Gomez, and I'm a Senior Manager of Engineering at Amazon. Today, what we're going to talk through is how to do coding on the whiteboard. Now, I know it seems really intimidating, but it doesn't have to be. There's a super structured way to walk through these types of problems. So what is it that we're looking for when we talk about whiteboard coding? Well, there are a few things that, as a company, we're trying to understand about your skill set. The first one is, do you know your computer science fundamentals? How are you on data structures and algorithms? The second is, do you have a heuristic for problem solving? Or do you just kind of randomly approach problems? And the third thing is do you write clean, logical, maintainable code that other people can readily understand? So why are we doing this? Well, because this is the kind of stuff that you do every single day at Amazon. You're going to be using the core principles of computer science to tackle super hard problems, and chances are at some point other people are going to be reading and maintaining your code. So how do we go about this? Well, there are a few key principles that I want you to keep in mind as you think about these types of problems. It's really not about, have you done every single sample problem that you found online? It's one, do you not jump into the problem immediately without looking at the space that it's in? Two, do you try and disambiguate the problem? Ask questions, try and understand the inputs and outputs. What are some of the edge cases that you need to be thinking about? And three, do you talk this out loud? This is a dialogue with your interviewer. It's, not a recitation. And so try and make sure that as you're writing code on the board, you're helping us understand what you're thinking and why, and how you're trying to solve that problem. And so once you've gone through this process, I'm going to talk you through an example problem of how to actually go through solving the problem on the whiteboard, talking out loud and thinking about all the things that you need to do in order to finish these types of problems successfully. When you interview at Amazon, you can expect somewhere between 2 and 4 questions like this, and so this is a good skill to build for your interview here. So why don't we jump right in? One thing I do want to remind you of is this is not a test of domain knowledge. If an interviewer asks you a question about rugby, we don't expect you to know the rules of rugby. This is about seeing, can you take an ambiguous problem, try and disambiguate the edges, and then come up with a reasonable working solution. So the problem that we're going to work through today is run length encoding. Now, it's fine if you've never heard of this. This is an older lossless compression algorithm from the 60s, 70s, and it was a way to compress image files. If you think of an image file as just a series of pixels that you can then compress, or run, if you will. What it looks like is this. So let's say I have a string of characters. A, B, B, C, C, C. If I encode this, what I should get is this, 4A, 2B, 3C. That's the desired output. So to write a function that's going to do this compression, we've got to do a few things first. Don't just jump into the problem. Think about, what are the ambiguities here? What are some of the edge cases or the gotchas that you might encounter when trying to solve this? For example, what happens if we just throw another A on the end there? Well, sometimes candidates think, oh, okay, this just becomes 5A. But that's not the case. Because order matters in run length encoding, what this should be is 1A. So this is going to start dictating the kinds of data structures that you might think about. A lot of candidates immediately jump to, oh, I need a hash implementation. But if order matters, yeah, you can do it with a hash map, but it's not optimal. So then I might think, okay, well, what about something like this, ABCD? Well, yeah, it's as inefficient as it looks. 1A, 1B, 1C, 1D. And that's okay. Like I said, this is just how the algorithm works. So now we're kind of teasing out the edges of this problem. So the next thing that you want to think about is, well, how am I going to actually solve it? Chances are this is a pretty straightforward iterative problem. I'm going to walk through each character in the string. I'm going to compare the character to the previous character. If it's the same, I'll increment some kind of counter. And if it's different, then I know I've hit the end of a run, and I'm going to add that to my output. In this case, I'll probably solve it in Java just because that's the language I'm comfortable in, but it's up to you. If you want to solve it in a language that you're more comfortable in, just let your interviewer know what you'd like to use. So with that, let's get started. So let's get into implementation. So now that we know that we're going to take an iterative approach to solving this problem, and we're just going to walk through a string array, let's start by thinking about our inputs and outputs and how we're going to specify the function we're going to write. Now, I'll just preface that I'm going to write this in Java. Got my function header because it's going to return a string and it's also going to take a string. So what do I want to do first? Well, we don't generally get very fussy about whether or not your input's validated. But for this case, because we've got a simple input validation that we can do, which is namely, is our input null, let's just do a quick check here. So if it's null, we return the empty string. Now we need to start initializing the variables that we're going to need to solve the problem. Because we're going to be walking through an array of characters, we should probably convert this to a char array. And also, because we need to track whatever the previous character was, we should create a variable to store that. And because we're going to need to keep a count of how many we've observed in the run, we need a counter. So now, let's get into the algorithm. Well, the first thing we want to do is see if the current is equal to the previous, and if it is, it's simple. We just increment the counter. Now, if it's different and it's not null, then we know we've hit a switch in the run. We've hit the end of a run and we're going into a new run. And that means that we want to append to whatever return string we're going to be building out. And one thing that I notice I've done here is I have forgotten to actually initialize my string builder. And that's okay. Like if you don't get everything the first time, that's fine. Just notate here, make it clear for the interviewer what you're doing. And so I'm just going to say, all right, I forgot this line. I don't want to erase everything. So let's initialize a string builder. Now it's going to be super tempting to use really shorthand variables or to just say, okay, we know we're initializing a new string builder, but I'm going to really recommend that you don't do this. Just take a couple extra seconds and write out everything fully. It'll be clearer for you. It'll be clearer for the interviewer. It'll also just result in overall clean code. It's a good habit to get in the practice of. So now that we have our string builder, we can actually go and append the previous char and whatever the counter value is. And then if these cases don't hold and we've already switched, well, then we need to reset some of our variables here. So we're going to say previous char is equal to the new char that we're iterating through, and our counter equals 1. And that terminates our for loop. But that means we've reached the end of our input array, so we need to spit out the last of our compressed values. So I will just make it very clear that I'm continuing my code over here. And then finally, I'll return the string. And there's our implementation. So we have our implementation, but there are a couple things that I want to point out that I was doing throughout the implementation process. You probably noticed that I was talking out loud the whole time, and that was very intentional. It's not something I'm doing for this. It's to let the interviewer know what I'm thinking and what I'm trying to accomplish with the code that I'm writing, because sometimes it's not obvious as you're going through the process. The other thing I did is you probably noticed these somewhat trivial comments. It might seem trivial, but it's a great cue for both you and your interviewer, and it shows that you care about writing maintainable code because someone's eventually going to look at it and try to understand what you were doing, and that first person, in this case, is your interviewer. And the other thing I was doing is, I can't really ask questions in this context, but you can ask questions to clarify with the interviewer, and the interviewer may interrupt and ask some questions with you. It's a dialogue, that's fine. If they cut you off, don't worry, they're just trying to get a little more information about what you're doing or what your approach is. So now that we have our implementation, let's test it, right? This is the next phase of structured problem solving. I'll just move this here for clarity. We know our input is A, B, C, C. So how do we test this? Well, I've got a couple of variables that I've been tracking this whole time. I've got the previous char. I've got my counter. So let's walk through it. At first, the previous char is 0 and my counter is 0. And when I get into my for loop, I'm here at the first A. So then I say, okay, well, does this equal the previous char? Nope. All right, so I can skip that and I set the previous char to A and the counter to 1. Go back to the top of the for loop. Now here I am at the second A. Okay, does this equal the previous char? Yes, it does. So we increment the counter. Then we go back out, and now we're here at B. And so does this equal the previous char? Nope. We go into this else if condition, and it's not 0. So then we say, all right, time to append to our string builder. So counter is currently 2 and A, our previous char. But then we reset everything. So this becomes B, and this becomes 1. So we go back to the top of the for loop again, and we've got C. Is C equal to the previous one? Nope. So this becomes, let's see, where am I? We append again, and we've got 1 and B. We reset this to C and 1. Go back to the top of the for loop. Here we are. Increment again. Oh, actually, no, we don't increment. My mistake. We actually come out of this, and then, yes, we have incremented. Sorry. And then we get to the last append, and we've got 2C. And this is what we return. So now you've tested, this kind of brute force solution with some pretty simple input. What a good practice is next is to start thinking about what kinds of input might break this. Well, maybe some obvious choices would be like A, B, C, D, or just a long run of the same characters. And I'll leave that as an exercise for you to try to see how you might break this. And then we want to talk about optimizations. It's really good to be familiar with how you compute time and space complexity. Let's go over time complexity real quickly. So we know that in this case, with our string input, we are going to walk through every character in the input one time. So for example, if our n equals 5, we are going to execute this for loop 5 times. So our time complexity is going to be O of n. So just try and get familiar with that and have that calculation ready for any kind of algorithm that you're going to be implementing. And then the next things that you want to think about are there any optimizations that you could perform? Are there more optimal solutions that you can talk through? There's actually a second part of this problem, which is decoding this string, and it has a bunch of interesting little tricks there. And I very much recommend that you try it as an exercise. We won't go through it today, but that's something that you can try at home. But I'll just leave you with practicing this, on a whiteboard so that you get familiar with the process of testing. So now that you've actually had a chance to see what a coding question on the whiteboard really looks like, I recommend that you take advantage of the many resources that are online, whether it's LeetCode or Career Cup or the great book Cracking the Code Interview, and try some of these problems for yourself. The other thing that I recommend is that you get a real whiteboard and you time yourself so that you get an idea of what it's like to do these types of questions, to solve these questions in an environment that's going to be a lot more like the interview that you're actually going to do. When you practice on a whiteboard, you'll have the opportunity to get good at some of these principles that we're looking for, whether it's CS fundamentals, your data structures and algos, your structured approach to problem solving, and writing logical and maintainable code, which is very different on a whiteboard than it is in an IDE. With that, I wish you best of luck. See you soon.